Hello and welcome. My name is Bosco and my student number is 1006-21465. And I'm gonna talk about the update scene and the display callback function. So in this update scene function, we first set up the game object called torus, and then we want to rotate it in X direction and with 10 degrees every time, and then we set up the light array on for the first element. The position takes effect 4, and we don't have a solid value for X because that's what we're gonna that's the direction we're moving in. And then we move 2 units up in Y direction, and we don't move anywhere in the Z direction, and the light has the intensity of 1. And after that we set up the camera movement, and we need to check if the player camera position in X direction is larger or smaller or equals to -10, and if the Boolean done movement is equals to true, then we'll make done movement equals to false. And on the other hand, if the player camera position in X direction is larger equals to 5, and the done movement is not equals to true, then we'll make it true. And if done movement is true, then we'll move to the left in X direction, or else we'll move to the right in X direction and both are by the value of 0.1. And then we use this for loop to update everything in the scene. And so in display callback function, we're gonna have forward and deferred shading in there. But before that, I want to talk about what they actually are. And forward shading, basically the idea is you render one object, and then you light it up with all the light source in the scene, and then repeat this process until the scene is fully rendered. And generally this is more expensive when including more than one light source, because every rendered object iterates over every light source for every rendered fragment. And it does waste a lot of fragment shader with high depth complexity, and most of these fragment shader outputs are usually overwritten. And for deferred shading, the idea is to leave most of the heavy rendering until later, and is generally less expensive when including more than one light source. And this shader consists of 2 passes. The first one is geometry pass, and the second one is light pass. And for geometry pass, what it does is it renders the scene once, and then retrieve all kinds of geometric information from the objects we stored in a collection of texture called gbuffer. And what gbuffer is, it's just collective term of all textures used to store lighting relevant data for the final lighting pass. And it is later used for lighting calculation. For light pass, the idea is to render the screen filled with quads and calculate scenes light for each fragment using electrical information stored in G buffer, and pixel by pixel we iterate over G buffer. And here where we have the implementation for rendering, and down here we have deferred rendering. So how is forward rendering done? So we need to set up obviously for the materials we need to bind it and then set it up, and then afterwards we bind the texture for sampling and then draw the quad and then unbind it after we use it. So for deferred rendering is very similar, but we have three mods we can look at. One is color, and then we have normal, and last we have position. And they're all done in a similar fashion. We bind it, we set it up, and then we bind texture for sampling. But this time we have to separate into three of them, 0, 1, and 2, and then also draw the quad and then unbind it after we use it.